Hello everyone, welcome to the second Beetleweight combat robot build progress video, where we talk about the wiring and electronics used in our Beetleweight combat robot Tekkadan. This setup here includes all of the electronic components that will go into Tekkadan, including the battery, the receiver, all of the speed controllers, and the motors. Of course, this does not just apply to Tekkadan, as most combat robots use this type of wiring scheme that is very similar to a remote-controlled aircraft. So, let's break down the entire wiring system and follow the path of the electricity to see how everything is set up. First, of course, we start with the battery. This is where all the power comes from, and without the battery, the robot's about as good as a paperweight. This battery right here is a lithium polymer battery. These are ideal for combat robots because they have a very high specific energy, which means for the same amount of energy, this battery right here is very lightweight. And weight is a very big concern, and you want a battery that is as light as possible. The other advantage of lithium polymer batteries is that they have a very high discharge rate, which allows us to draw a lot of current from the weapon motors and drive motors. This right here is a 3S or 3-cell battery. The S means the number of cells wired in series. So right here we have 3 cells wired in series. The amount of cells wired in series determines the voltage of the battery. Higher voltages will mean faster weapon and drive motors. However, you can't get infinitely high cell counts because for the same capacity, higher cell count in series will mean a bigger battery. So 3S allows us to compromise for a relatively high speed for the weapon and drive motors, but at the same time, it is small and light enough to fit in the robot. We then follow the power from the battery through this wire, through these connectors, and into the rest of the wiring for the robot. On the positive side, it is directly split from the connector to the 3 speed controllers, the 2 drive and the weapon electronic speed controller. However, on the negative side, before the split, we have a switch. This switch is very important as it is the main switch for the entire robot. It's placed before the split, so when this is turned off, the entire robot shuts off. This is very important as it allows us to keep the robot off in between fights to make everything safer and also to conserve power. After the switch, the negative side is also split off into the 3 electronic speed controllers. So now let's get to the electronic speed controllers themselves. So they are very important because they control the speed of the drive and weapon motors and control how much power is sent to each one of them. And as for the drive motors, it also controls the direction the drive motors spin. First, let's get to the weapon electronic speed controller. This is a 40 amp brushless ESC. 40 amps because it needs to be able to handle the about 40 amps that the weapon motor draws, and brushless electronic speed controller because the motor is also brushless and they have to be compatible. The drive electronic speed controllers are not brushless. They are brushed because the motors are also brushed. As for the motors themselves, the weapon motor is a 420 watt brushless motor, and of course it is controlled by the weapon ESC. You can see with brushless motors there are 3 wires versus with the brush motors 2 wires. So the drive motors are FingerTech Silver Spark motors. These have a built-in gearbox in here that gears the motor down 50-1 for our motors. However, there are other options. This gearing allows us to have more torque at the wheels, which allows us to push our robot a little bit better, and also because our robot's drive system does not need to spin at a really high rate. It is also important that the left drive motor and the right drive motor have independent left and right drive ESCs. You can see the left one is wired only to the left motor, and the right one is only sending power to the right motor. This is very important because it allows for independent control of the left and right drive sides, which is needed for differential speeds on the 2 wheels, which is needed for the robot to steer. Say you want to turn left, your right wheel will have to be spinning faster, and your left wheel will probably be spinning in reverse, and that will allow the robot to turn left. To control everything, we have the radio receiver. This receives signals from the transmitter which you use to control the robot. And you can see there are 3 signal channels that are currently attached for the 3 ESCs. The weapon ESC and the 2 drive ESCs are all connected to the receiver, and the receiver tells the ESCs what to do through signaling. You can see the throttle channel of this ESC. This ESC is an aircraft ESC used for remote controlled aircraft. So this channel is originally used for the throttle of a remote controlled aircraft, and the throttle channel is then sent through the signal into the through this wire into the weapon ESC. So then by controlling the throttle on an aircraft controller, you can control the throttle of our weapon motor. The other 2 connectors for the left and right drive ESCs are connected to the elevator and aileron channel. And this allows us to do what is called an elevon mix in radio-controlled aircraft. And when you do an elevon mix, when you put the elevator stick forward, the drive motors will all spin in one direction, allowing the robot to move forward. When you put the elevator stick backwards, it'll allow both drive motors to spin backwards, allowing the robot to back up. But also, when you turn the aileron stick to the left or to the right, it'll change the drive motor so one spins forward, the other spins backwards, allowing the robot to turn properly. So this radio receiver here acts as the control for the weapon and the drive ESCs. And that is all for our wiring video. Stay tuned for future videos where we will break down other progresses we made with our robot, Tekkadan, and other robots in general. This is Team Embarrassing Engineering. Thank you for watching.